Welcome to the next module in our training on adverse childhood experiences and toxic stress. In this lesson, we'll cover the immune system and metabolism. The purpose of this module is to understand normal metabolism and the impact of imbalanced cortisol on your metabolism, how ACEs and toxic stress impact the immune system, the different roles of the immune system, and inflammatory markers in toxic stress. Now let's talk about metabolism and how it's impacted by stress. In normal metabolism, the digestive tract breaks down carbohydrates into glucose, a form of sugar that enters the bloodstream and is taken up by cells to be used for energy. This is done with the help of the hormone insulin. The body also uses fats and proteins for energy. It's important to maintain a healthy balance. When things aren't balanced, we're at risk for chronic diseases such as diabetes and heart disease. With metabolism, well-regulated cortisol levels are important. Prolonged elevated cortisol levels as a result of toxic stress can change your body physically. Cushing's syndrome involves the HPA axis causing excess cortisol release from the adrenal glands. When the normal function of the glucocorticoids becomes exaggerated, a wide range of physiologic responses can be triggered. An example of this is Cushingoid appearance, characterized by a buffalo hump at the top of the back, purple striae or stress marks, moon fasces, easy bruising, abdominal obesity, and weak bones. Elevated cortisol levels can cause high blood sugar by opposing insulin, which, as we discussed, helps transport sugar to cells to be used for energy. Prolonged elevated cortisol levels also lead to an increased risk of obesity, diabetes, heart disease, and osteoporosis, or weak bones. ACEs themselves don't lead to Cushingoid appearance. It's an extreme example of what can occur when the body overproduces cortisol as a result of long-term stress. Remember, cortisol is responsible for the long-term stress response, and it also plays an important role in metabolism by increasing blood sugar, stimulating fat deposition, and breaking down nutrients in our diet such as protein, fat, and carbohydrates. Too much cortisol suppresses the immune system. Let's take a quick overview of the immune system. There are two main roles in the immune system: fighting disease and stimulating the HPA axis. Our immune system is responsible for fighting off infections, invaders, and cancer cells in our body. The immune system interacts with the brain by signaling and stimulating the HPA axis. The HPA axis is closely connected to the body's stress response. The HPA axis also has the ability to activate the immune system. The immune system is complex and involves different cells that play a role in both the short-term and long-term response against disease. An imbalanced, increased immune response can lead to allergies, inflammatory or autoimmune diseases. A poor immune response can lead to infections and an increased risk of cancer. Cytokines are proteins which are secreted by immune cells and can travel anywhere in the body. There are two types of cytokines: pro-inflammatory and anti-inflammatory. Inflammation is your body at work during the healing process. A cytokine's job is to activate or suppress inflammation. You might think of cytokines as inflammatory regulators. If you need extra inflammation, your pro-inflammatory cytokines help out. If you need to reduce inflammation, your anti-inflammatory cytokines help. Have you ever noticed when you have a cut, the area becomes red and inflamed? Well, cytokines play a big part in that. They sent out the alert to begin the inflammation process to begin repairs. Cytokines are an important part of how the immune system interacts with toxic stress. Why? Well, because they help mediate acute and chronic inflammation, which we'll describe more in detail in a bit. Cortisol levels are important in helping the immune response carry out its main job, fighting disease. An imbalance of cortisol can directly affect the immune system. The immune system is an intricate pathway, and it's important to note that it's mediated by the relationship between cortisol, cytokines, and the HPA axis. When cortisol levels are too high, the immune response is suppressed, which decreases the secretion of cytokines, leaving the body at risk for getting infections. When levels of cortisol are too low, the HPA axis will sense that it needs to make more cortisol. Cytokines then increase and activate the HPA axis, which revs up and works to produce more cortisol. Remember that cytokines play a role in the inflammatory response. So more pro-inflammatory cytokines means more inflammation. This can cause unwanted inflammation when the body isn't actually sick, overproducing inflammation and pain. Let's take a look at inflammation more closely. Inflammation can be classified in two categories, acute and chronic. Acute inflammation helps to heal tissue damage from infection or injury. We recognize it in the form of redness and heat. Have you ever sprained your wrist? How do you know it's sprained besides the immediate pain? It becomes red, swollen, and hot. The next time you have a small injury, watch the inflammation and healing process at work. Chronic inflammation occurs when the inflammatory response is out of proportion to the threat or isn't shut off once the threat has been controlled. Chronic inflammation can cause more damage than the threat or disease itself and is an underlying cause in diseases like cancer, diabetes, asthma, heart disease, and atherosclerosis. Atherosclerosis, hardening and narrowing of the arteries, is a usual cause of heart disease, strokes, and peripheral vascular disease. Together, these are called cardiovascular disease. Cardiovascular disease is the #1 killer in America, with more than 800,000 deaths in 2005. Heart attacks happen because arteries become clogged with plaque, and a contributor to clogged arteries is inflammation. If arteries are inflamed, swollen, and clogged, it becomes more difficult to get blood and oxygen to the heart, increasing the risk for heart attack. This is why intervention of chronic stress is so important, to help aid in the prevention of chronic inflammation. Prevention will help people avoid life-threatening diseases in adulthood. Biomarkers are chemical traces in the body that indicate disease or inflammation. For instance, with diabetes, glucose levels or sugar levels are a commonly used biomarker for determining if a person has diabetes. Unlike an acute inflammation, which may show redness and heat in a localized area, we can't see chronic inflammation. So how do we know when someone has chronic inflammation? We measure inflammatory biomarkers, C-reactive protein or interleukin-6. Children who are maltreated were 1.8 times as likely to have an elevated level of highly sensitive C-reactive protein in adulthood compared with non-maltreated children. This association was still significant even when the effects of other health-damaging behaviors like smoking or weight gain were taken into account. Let's go over our module takeaway points. Metabolism refers to how our body takes in, transports, and uses energy. Metabolism is also impacted by cortisol. A cortisol imbalance can lead to conditions such as obesity, diabetes, and heart disease. Two important roles of the immune system is to fight disease and to help activate the HPA axis. The immune system activates the HPA axis through cytokines. Cortisol levels impact cytokines and the immune system, so it must be properly balanced. There are two types of inflammation, acute and chronic. Acute helps the body heal from injury or illness. Chronic inflammation can cause long-term damage and illness. Chronic inflammation can be measured through biomarkers like CRP and IL-6. This concludes our module on the immune system and metabolism. Thank you for participating in this training. Center for Youth Wellness, where health begins with hope.